Hi students, this is Rasul speaking. I'm going to discuss about topic 5, continuous probability distributions for course FHMM 1214, Mathematics for Social Science. In this chapter, we will learn more about continuous random variable and mainly normal distribution and some topics related to normal distribution. First of all, what is a continuous random variable? In this variable, values are not countable and values are described over an interval or intervals. Some examples: height of a person, time taken to complete an examination, weight of a baby, the price of a house, and length of life of a particular product. In continuous probability distribution, values of probability are calculated based on the interval for x. Total probability is 1. Area under curve of probability distribution is 1. And we are able to calculate the value of probability for different intervals in this area. For example, probability of the value of x between a and b or a to b. And we have an interval of the x, for instance, 65 to 68. In continuous random variable, we cannot calculate the single value of x probability. Probability of single value of x in the concept of continuous is 0. That's why in these types of variable, all these values are same. We don't mind about equal to x or not equal to x. Only more than and less than is important. Because the single value of x probability is 0, then these four values are same in this concept. Normal distribution is the most widely used continuous probability distribution. And it is based on assumption. We assume our variable follows a normal distribution. Normal distribution is a bell-shaped curve like this. And left side distribution and right side are same and symmetric. We say there is a symmetric distribution. And in normal distribution, we need to have the mean of the variable and also a standard deviation. We show the mean with mu and a standard deviation with sigma. And we say x is a continuous random variable belong to the n normal distribution for the variable with mean of mu and variance of sigma square. Sigma square is variance and sigma is standard deviation. And in the middle of this distribution, we have the value of mean, mode, and median. This one is for x, a continuous random variable. The properties of the normal distribution, as we already explained, is a total area under the curve of this distribution is 1. Total area means total probability is 1. Because it is a symmetric, so left side and right side each is equal to half values of probability. And mean in the middle of this curve, value of mean. And because the mean, mode, and median are considered same in this distribution. And because in the middle we have mean, median, and mode, then distribution in the left side and right side is same. Left side and right side are same. We have also a standard normal distribution. It means we can convert all the values of continuous random variable to a standard value which is named Z score or Z. In this assumption, we considered all converted to a standard form, which a mean of 0 and variance or a standard deviation of 1. So in this case, in the middle, we have 0 is a value of the Z when the mean of the continuous random variable is in the middle. Then for this one, we need to have a table to find the different value of Z. First, we learn how to find the values of probability for different values of Z. This table helps us to find the value of probability for all different continuous random variables. It means first we convert X to Z, then we can use this table to find the value of probability. How to find? For example, in this, I choose the 0.8 value of Z is here in vertical. Second decimal comes from the first row. If I want to read the value of Z from this table, Z is equal to 0.85. 0 point in the first column and second decimal comes from the first row. If you find the intersection of these two lines, intersection is 0.1977. This one is the values of the area for value of Z more than 0.85, like this value of area in the right side, and this table already prepared for positive values of Z. You can have a look at the result. Probability of Z more than or equal to 0.85 is equal to this area is 0.1977. This area like this will be 0.1977. Because the single value of X has a probability of 0 also, this one you can consider Z more than 0.85 also is 0.1977. Is the same, more than equal or more than 0.85 is equal to 0.1977. Some properties of the normal distribution and how to find the values of area or probability for different interval of Z. First, if you have this distribution, the value of the area or probability more than 0.75 is same with the value of area less than Z is negative 0.75. It means both have same value, 0.2266. This one is a property of normal distribution, is a symmetric. Because it is symmetric, then the left side and right side you can find equal values for these two areas. Another thing, the value of probability for Z more than 0, Z in the middle is 0, and more than 0 is half, and also less than 0 is half. The standard value of continuous random variable is Z with the value of 0 in the middle. In the right side, area is half, and left side also area is half, and total probability is 1. And another thing, the total probability is 1. When I can find this area from the table, probability of Z more than 1.62, then I can deduct this value from total is 1 and find the blue area. Blue area is 1 minus probability of Z more than 1.62. In fact, this area is a value of probability for the value of Z less than 1.62, which is the final is equal to 0.9474. Now we have some examples to find the different values of probability for different interval of Z. First of all, Z more than 1.19 and less than 2.12. And Z is a standard value. So for this one, Z is more than 1.19 and less than 2.12 is this area. How to find this area? In the table, we can find area more than any value of Z. So first, I find the probability of Z more than 1.9, this area until the infinity like this, and minus probability of Z more than 2.12. The balance is my interval, difference between these two areas. And then I have 0.1170 minus 0.017. These two values comes from table 1. Table 1, the values of probability based on different values of z. And then you can, the final answer is 0.1. B, what is the value of z more than negative 1.56 and less than 2.31? One value is negative, one value is positive. Because the total area is equal to 1, so I can deduct this part and this part from 1, then the balance is my answer. It means 1 minus probability of z less than negative 1.56 and minus probability of z more than 2.31. Then, because the symmetric z less than negative 1.56 is equal to z more than 1.56. When I reach this part, both value of z in these brackets are more than a positive value, then I can go to the table 1 and find the values of probability from table as we explained already how to find. Then these two values comes from table 1. These two values comes from table 1 and these two area deducted from 1, the balance is my answer. This area is 0.93016, this area. Next example is z more than negative 0.75. Z more than a negative value like this. Negative 0.75 in the left side for z. Then I need all this value, this area. This area. Then I know the total probability is 1. So I say 1 minus probability of z less than negative 0.75 is my answer, 1 minus this. But symmetric property of normal distribution, I know the probability of z less than negative 0.75 is same with probability of z more than 0.75. Then from table 1, I can find this value 0.2266 and my answer will be 0.7734. If the value is between 0 and the large value of z 5.67, when we have the values of z more than 4, the values of probability is very, very small. Then, for example, this one, if you go to the table, maybe you cannot find the value of z 5.67 in your table. It means because the value is too small and you can consider this one, this part more than 5.67 is almost or approximately is equal to 0. That's why for this one, okay, z more than 0 I know is half. Z more than, because this area between 0 and 5.67. But value of z, area for value of z more than 5.67 is very small. Then I can consider approximately 0.5 minus 0 and this value is equal to half because the value of z more than 4, the area is very, very small. 5.67 is the large value of z in normal distribution. Another example, if the both values are in this interval are negative, what shall we do? Okay, again we use symmetric property of normal distribution because when you have the values negative, you can go to the right side and find the positive values in this form. So these two areas are same. Negative 1.7 to negative 0.88 is same with 0.88 to 1.7. Then you can change this one to the positive values. They are same, and you know when we have two positive values, area for z more than 0.88 minus area for z more than 1.7, the balance is my area, and my answer will be based on the values from table of normal distribution or table 1 in your course. You can find that these two values and difference is 0.1448. Answer. Okay, how to standardize a normal distribution. Already we learned how to find different values of probability for different interval of z. Then you can consider your continuous random variable is x belong to the normal distribution with the value of mean and variance. And the standard deviation square is variance. So you can use this is a theory how to convert value of x to the standard value. X minus mean divided by standard deviation is equal to z. When you want to solve a question for continuous random variable, first you need to convert value of x to z, then go to the table and find the value of probability. So that this value is called z value or z score also. Z is a standard value of continuous random variable. In this concept, you know that because the mu in the middle for the x distribution of x, then distribution of z, because the z in the middle is 0 and value of the x in the left side is less than mean, based on the formula of z, that in the left side we have negative values for z and in the right side we have positive values for z. Example, x belongs to the normal distribution with the mean is equal to 40 and variance is 25. Because variance is 25, then standard deviation is 5. Standard deviation is 5. How to find probability of x more than 55? Mean is 40 and standard deviation is 5. Probability of x more than 55. I can use the formula for z. Z is x minus mu divided by standard deviation. 55 is the value of x and 40 is mean and 5 is standard deviation. Then you need to calculate first the value for z based on the value for x. If you try this one, you can get z more than 3. For 3, you can go to the table 1, and because z more than a positive, you can find directly from table like this. For z more than 3, the value of probability or area is 0.00135. Next example, probability of x less than 49. Again, you need to convert 49 to the value of z. It means z less than 49 minus mean divided by standard deviation. Z is probability of z less than 1.8. This one is a positive value and probability of z less than this value. Your table gives you the value of probability for a value of z more than something, more than a positive value. So I know the total probability is 1. So 1 minus this small area in the right side is equal to this area. I want this area, but this area can come obtained from table. From table, probability of z more than 1.8 is 0.0359, and when you deduct from 1, you can get the answer for this example. Next example, x between 42 and 50. Again, you can keep same direction for your inequality or for your interval. Then we have z between 42 minus 40 divided by 5. You can see the 42 comes here and 50 here. Both minus mean is 40, and both divided by standard deviation is 5. Then if you calculate these two values, z will be between 0.4 and 2. When we have two positive values, okay, probability of z more than a smaller one like this, 0.4 and 2. This area is z more than 0.4 and this area is z more than 2. The balance is my answer. So I need to find probability of z more than 0.4 from table and probability of z more than 2 from table. The balance is equal to 0.32185. These two comes from table. These two values come from table. Another example, let x be a continuous random variable, is normally distributed, is keywords for the question. Normally, then we can use the rules of and properties of normal distribution. Mean is 25 and standard deviation is 6. What is the probability that x has a value between 29 and 36? So you can form your mu is 25 and standard deviation is 6. So your distribution, normal distribution, mean is 25 and variance is 6 squared. Standard deviation power 2. What about this 29 and 36? So you can follow the same formula, convert x to z. Convert x to z. 29 minus mean divided by a standard deviation, 36 minus mean divided by a standard deviation, and then you have the value of z between 0.67 and 1.83. Both values are positive. You can go to the normal distribution table and find probability of z more than 0.67 and then minus probability of z more than 1.83, as we explained already when we have two positive values for interval of z. Then these two values comes from table, and then the difference between these two is my probability. How to apply the normal distribution to solve the probability questions? Okay, so in this example, we have an electrical component normally distributed with a mean of 800 hours and a standard deviation of 12 hours. We need to find find the probability that a randomly selected electrical component will last more than 818. It means X is more than 818. How to find this one? Okay, we find the mean is 800 and a standard deviation is 12. So we need to find probability of when X belongs to the normal distribution with mean 800 and variance of 12 square or standard deviation of 12. X more than 818, the first part A. 818 convert to Z, you need to deduct mean from this value and then divide it by 12 standard deviation. If you calculate this one, you can get 1.5, and from table you can find the answer 0.0668 from table for value of Z more than 1.5. Then if you have for the part B, find the probability that a randomly selected will last more than 780 hours. So for this one, you can go to the second part, B, X belongs to the normal, and then we need to find probability of X more than 780. So Z is more than 780 is X minus mean divided by standard deviation. Value of Z is more than negative 1.67. Because normal distribution is symmetric, then you can find the probability of Z more than 1.67, but you need to deduct from 1 because this one is more than a negative value. First, you need to deduct from 1, and then using the symmetrical property of normal distribution, you can find the Z more than 1.67. From table, you can get this answer, table, and then you can have 0.9525 as a final answer for this one. For the next example, for part C, find the percentage of electrical components will have lifetime of less than 760 hours. So for this one, for part C, we need to find probability of X less than 760. Again, same thing we do. Z is less than 760 minus mean divided by standard deviation. And then you have Z less than negative 3.33. This one is the left side because Z is negative and less than a negative is the value of probability for Z more than a positive same value is a symmetric property. Then you can find the value of probability for X less than 760 is 0.0043. Then this one, in fact, also the probability is a percentage. You can time by 100 is you can find percentage. Any value of probability times by 100 is a percentage of the number of X, and then you can find the values based on percentage, values of probability based on percentage also. Another example, a racing car is one of the many toys manufactured. This toy is manufactured by this corporation, and assembly time is a X for this question. Follows a normal distribution. How long it takes to assembly this toy? The mean is 55 minutes and a standard deviation is 4 minutes. The company closes at 5 p.m. every day. If a worker starts to assemble a racing car, is a toy, at 4 p.m., what is the probability she will finish this job before the company closes for the day? It means 4 p.m. and to 5 p.m. that company will close. This one will be 1 hour. So she needs to finish this one less than 1 hour, less than 60 minutes, because she has only 60 minutes. That's why, okay, X is the time taken to assemble a racing car, and mean is 55 minutes, and standard deviation is 4, and X belongs to the normal distribution with the mean and variance. So find the probability the worker can assemble in less than 60 minutes, because 4 p.m. to 5 p.m. is 60 minutes. So it means X is less than or equal to 60 minutes. Again, I remind you, we don't mind about equal or not equal, because in continuous concept, both values are same. Less than or equal, or less than, or smaller and equal. Z less than 60 minus 55 over 4, because the mean is 55 and the standard deviation is 4. When you convert to this, is Z less than or equal to 1.25. But my table only gives the value of Z more than a positive value. So I know the total probability is 1. Then 1 minus probability of Z more than 1.25 is my answer. This one, Z more than a positive value, easily is obtained from table. From table, I can find 0.1056. Then the balance is 0.8944. Is answer is a probability that worker can assemble this one before the company close is 0.8944. The probability. Now another example, the time taken by a postman to deliver mails in Jalan Petaling is normally distributed with mean of the 12 minutes and a standard deviation of 2 minutes. He delivers mail every day. We need to find the number of days during the year when he takes between 9 and 13 minutes to deliver the mails. It means that we need to find percentage and probability, then calculate based on the number of days for 1 year. First, we need to find the probability that he delivers between 9 and 13 minutes. The delivery time is between 9 and 13 minutes. So the mean is 12 and the standard deviation is 2. X is time taken by postman to deliver mails, and normal distribution with this mean and variance based on the value of mean and standard deviation. So what is the first probability of the delivery time? Is between 9 and 13. 9 is a value of X, both minus mean divided by standard deviation. Then you can find the probability of Z between negative 1.5 and 0.5. One value is positive, one value is negative. So you need to consider total probability is 1. 1 minus probability of Z, and also symmetric properties of normal distribution, Z more than 1.5 and Z more than 0.5. If you deduct these two values from 1, you can get the value of probability. These two values are obtained from table 0.0668 and 0.3085. Then you deduct these two values from 1, you can get the probability for this. But during a year, we have 365 days. If you time this one by 0.6247, this one is a number of days. The delivery time will be between 9 and 13. This one. So you can consider 228 days approximately is equal to 228 days. But the last part for this topic is when we have the area or probability, how we can find the value of Z or X. So far, we find the values of probability based on the values of X and Z. Now we want to try when we have area, how to find the value of Z or X. For example, this one, the right tail is 0.005, area is 0.005. When the area is 0.005, we need to find the value of Z. What is the value of Z for this area? Area is 0.005. So for this one, you need to go to the table 2, because the table 2 some convenient values for the area already prepared in table 2. In fact, you have probability of Z more than a value is equal to 0.005. What is this value of Z? What is the value of Z in the curve and in the horizontal axis? How to find this value? Easily you can go to the table 2. Table 2 is a below of table 1. You can find the sum area are given and value of Z also given. Because my area is 0.005 in this example, I can find the value of Z for this area when the area is equal to 0.005. The value of Z is 2.5758. Then because you say right tail value of z must be positive, because in right side z is positive, then the value of z is 2.5758. But next example is in the left, when the left tail we have area of 0.05. In the left side you have 0.05. You know the value of z in the left side should be negative, because in the middle standard value of continuous random variable is 0. Then in the left side we have negative value for z. So how to find the area? Again, you can go to the table 2 and find which value of z is for 0.05. I go to the table 0.05 area, the value of z is 1.6449. But this one is for positive values, right side. For the left side, value of z is negative. I need to time by -1. And my value for z is 1.6449, correct? But my question in the left tail, z is negative 1.6449. Because it is in the left side. Z in the left side is negative. Another example, ABC company produces many types of soft drinks. In this example, X is the amount of soda in each can of cola, which has a normal distribution. Mean is equal to 12 ounces and a standard deviation of 0.015 ounce. 90% of cans of cola contain less than K ounces of soda. Determine the value of K. Because the 90% are less than a value of K, K must be in the right side in normal distribution curve. X belongs to the normal distribution with a mean of 12 and a standard deviation of 0.015. Probability of X less than K is 0.9. Because it's saying 90%. Then probability of Z less than K minus 12 divided by 0.015 also is 0.9. Because total probability is 1 and 100%, you can find this value. The Z more than this value is 1 minus 0.9 is 0.1. And also from the table you can find for 0.1 from table 2, you can find this value based on the value of area. Area is 0.1. The value of Z is 1.2816. It means the probability of Z more than this value is 0.1, 10%. 90% less than this value, 90%. 10% more than this value. So probability of Z more than 1.2816 is 0.1. And Z less than 1.2816 is 0.9. Now, you can compare these values, and after find the value of 1.2816 from table 2, you can let equal these two values. 1.2816 is equal to K minus 12 over 0.015. Compare. And then you can find the value of K. K is 12.02 ounces. It means that, okay, I show you in the table also how to find this value. For 10%, we have 0.1. 1 minus 0.9 is 0.1. And the value of Z is 1.2816. Next example, X belongs to the normal distribution of 4 and 3 square as variance. It means a standard deviation is 3. If the probability of X more than or equal to M is equal to 0.1151, find the value of M. So first you need to find the value of Z. Value of Z. Normal distribution with the mean of 4 and standard deviation of 3. And in this table, you can find the value of Z when the value of X more than or equal to M is 0.1151. Then Z more than this value minus mean divided by standard deviation. Also probability for this value is equal to 0.1151. Area is 0.1151. Because the value has 4 decimal, better go to the table 1 and find the value of Z for this value of area. How to find 1.2? We show in the table how to find this value. We have the value of area is 0.1151. What is the value of z for this value? You can see the z will be 1.2, and for this value of area, the second decimal is 0 for z. So the z is 1.2. We find z is equal to 1.2 from this table. Then the value of probability for z more than 1.2 is 0.1151. Probability of z more than 1.2 is 0.1151. Then you can compare and let equal these two values. For z, 1.2 is equal to m minus 4 over 3. And then you can find the value of m is equal to 7.6 for this example. Another example, same the distribution, mean is 4 and the standard deviation is 3. Probability of x less than m is 0.25. Because less than m is a value of probability is less than half, so this value must be in the left side. So how to find the value of m? You need to find also value of z for this value of x, which is equal to m. So therefore, this distribution, normal distribution, x less than m is 0.25 or 25%. This one, z x less than m. So if you consider z for this one, value of z for less than this value is equal to 0.25. But using the symmetric property, you can use the table to find the value of z for this area, 25% in the right side. Then this value will be 0.6745. You must time this value from table 2. If you go to the area of 0.25, you can find the value of z is equal to 0.6745. Because our z, in fact, in the left side, using the symmetric property, you can use same value of x, but time by -1 is -0.6745. In fact, you have something like this. X less than m is 0.25. Z, probability of z less than m minus 4 over 3 is 0.25. Because the probability of x less than m is 0.25 and probability of z less than this value is 0.25. And also from table, I find probability of z less than this value, negative 0.6745, also is 0.25. I compare these values. Finally, I have m minus 4 over 3 is equal to negative 0.6745. And m is 1.977, the value of m. Another example for this topic is a study has shown that 20% of all college textbooks have a price of 90 ringgit or higher. And a standard deviation for this distribution is 9.5 ringgit. We don't have the value of mean in these examples. Based on the information given, we need to find mean price, mu, or mean of x for this question. How to find mean? We know the probability of x more than or equal to 90 ringgit is equal to 0.2 or 20%. Then, because the probability of the price more than 90 ringgit or equal to 90 ringgit, probability of x more than this value is 0.2. Then I can find mu through the normal distribution properties. Okay, probability of x more than 90 is 20% or 0.2. And also for z, if I consider that this value z in the middle is 0 and more than a value of z, we have 0.2. From table, I can find 0.8416. From table 2, if I find the area is 0.2, then z is equal to 0.8416. It means probability of z more than 0.8416 is equal to 0.2. Then x is 90 ringgit minus mu divided by 9.5 is 0.2. Probability of z more than this value is 0.2. I can let equal this value from table 2 because it is the right side is positive, is equal to this value, compare. And then find the value of mu. because I know the answer for probability, and based on these information given, I can find the value of mean for this example. And this one is that's all for topic 5. Thank you so much for watching this video. Life is good, just keep trying, and I wish you all the best. Goodbye.